Good morning. Welcome to our lesson on motion, which is part of kinematics, a branch of physics that studies motion. So when you look around you, you see objects in motion. So you see the sun moving, you see the airplane, the ball moving. So basically, motion is a term given to anything that is moving, or it refers to a movement. So it could be a moving planet around the sun, or we call it circular motion, or somehow elliptical motion. We also have straight line motion, just like this airplane moving to the right and this soccer ball moving vertically up and down. So how do we know if an object has moved? So there are three things you have to remember to when you can say that an object has moved. So there has to be number one, change in position. So an object that is not anymore in its original position is said to be moving. So if its first position is position A, then after a while it is now in position B. Therefore, we can say that an object has moved because it's not anymore in its original position. Second is an object has to have certain speed. So if you look at the speedometer of your car and it says there 0 km/h, then you can say that the object is not moving. But if it says that it is around 90 km/h, then the object or the car is moving at 90 km/h. The third that you are going to remember is an object has to have acceleration. And if an object is already moving and it's increasing its motion, therefore there is acceleration. And then if an object is accelerating, then it has to have move, or it has to have movement. Now let us go through the definition of the terms that you are going to use all throughout discussion. We have distance, the length between 2 points. If we have point A and point B, as this space shuttle moves from point A to B, then the distance between point A to B, or the length between point A to B, is what we call distance. So for example, the measured length is 5 kilometers, then the distance between A and B is 5 kilometers. Displacement is just distance with direction. So if the distance here is 5 kilometers and that the object is moving to the right or to the east, then its displacement is 5 kilometers east. Or if it is moving from B to A, then we can say that the displacement is 5 kilometers to the west or west. Or if it's going up, then that is north. Going down, then that is south. And we can also use the convention positive and negative. So we already know that in our Cartesian plane, we have positive x to the right, negative x to the left, positive y to upward, and negative y downward. So in this case, if the object or if this shuttle is moving from A to B, then we can say that it is moving, or its displacement is positive 5 kilometer. If it's moving from B to A, then its displacement is negative 5 kilometers. Speed is how fast an object is moving. So it has a formula, distance over time. So we divide the total distance over the total time covered, then that's the speed of the object. So speed does not need direction since it is a scalar quantity. So we can say that an object is moving 5 meters per second. Velocity is speed with direction. So if the speed is 5 meters per second, if the object or the car is moving to the right, then that is 5 meters per second east. If it's moving to the left, that is 5 meters per second west. If it's moving upward, then 5 meters per second north. Then downward, 5 meters per second south. Again, we can also have it in terms of positive or negative. So if it's going to the right, then the velocity should be positive 5 meters per second. If it's going to the left, then it should be negative 5 meters per second. And if it's going upward, it should be positive 5 meters per second. And if it's going downward, that should be a negative 5 meters per second. Acceleration is how fast the velocity changes. So this is the time when the velocity either increases or the velocity decreases or its direction changes. So in this diagram on the left, so you have here a motorcycle driver is speeding up. So therefore the velocity increases, therefore the object accelerates. Its direction is to the right. Then if it's slowing down, the velocity decreases and its direction still is to the right. Now in this case, if you get a negative value of your acceleration, then that means the object is slowing down. Now that depends on the direction of the velocity. Do you follow? So if it is slowing down, the value of your acceleration is negative. Or if velocity decreases, your acceleration has a negative value. If velocity increases, it has a positive value. And then both of this acceleration is to the right, and its velocity also is to the right. In the case of slowing down, velocity is to the right, then acceleration is to the right. In the case of slowing down, velocity is to the right, but acceleration is negative, so it's going to the opposite direction. Meaning to say, velocity and acceleration is in the opposite direction. The result is a velocity that is decreasing in value, or the result is a slowing down motion. And the third example here is that the velocity is just the same, but the direction changes. It could be that it is going, let us say, downward or rounding a curve, the one you call banking when you are driving on a motorcycle. So let us say you are maintaining your speed, but you are changing your velocity, then there is already acceleration. You're changing your velocity because you're changing the direction of your speed, then your velocity changes, then there is acceleration. So all you have to remember is that if velocity changes, be it the magnitude by decreasing or increasing, or be it the direction or the change in direction, then there is acceleration. Then we also have other terms that we need to understand. We have constant speed. That means that the speed is not changing. So let us say an object is moving 5 meters per second for 10 seconds, and then after 10 seconds it is still moving at 5 meters per second. Then the object is having a constant speed. Instantaneous speed refers to the speed at that particular moment or instant. So, for example, when you look at your speedometer of the car, you see that the reading is 90 km per hour. Then the instantaneous speed of your car is 90 km per hour. Let's say after 3 seconds, it is now 70 kilometer per hour. That means you're slowing down. That means the instantaneous speed of the car is at 70 kilometer per hour. So whatever is the reading, that is the speed at that particular instant. And we call that one instantaneous speed. Average speed refers to the total distance over time. So that is, let us say if you have traveled from north to south, let us say that's 100 kilometers, and then the total time is 5 hours, then your average speed is 100 divided by 5 hours, then that will be 20 kilometer per hour. So that's your average speed. But it does not mean that your speed all throughout the travel is 20 kilometer per hour. It could be that at some time your speed is greater than 20 kilometer per hour, and it could be that at some time you have a step over, or let us say you're slowing down at some part of your travel, then it has to be compensated by a speed more than 20 kilometer per hour to get an average of 20 kilometer per hour. So let us practice. Let us now check our understanding and the terms that we have covered. So what is the average speed of a cheetah that sprints 100 meters in 4 seconds? So we are asked of average speed, so the formula is total distance over total time. In this case, total distance is 100 meters divided by 4 seconds. So that will be 25 meters per second. If it sprints 50 meters in 2 seconds, then that will be 50 divided by 2, still 25 meters per second. So the solution is here. So average speed is distance covered over time interval, and that is 100 divided by 4 or 50 divided by 2. Both of them equals 25 meters per second. So in both situations, the speed of the cheetah is the same. If a car moves with an average speed of 60 km per hour, it will travel a distance of 60 km. Letter A, how far would it travel if it moved at this rate for 4 hours? So we are asked of how far, meaning we are asked of distance. So if you cross multiply speed equals distance over time, you will get distance equals speed times time. So the same formula for B, because we are asked how far would it travel in 10 hours. So the solution would be distance is equal to 60 km per hour times 4 hours, and we have this 60 km per hour times 10 hours. So for letter A, you have 240 kilometers, and letter B, you have 600 kilometers. So since it is now traveling for longer hours, so from 4 hours to 10 hours, so it has now reached a 600 kilometer distance. In addition to the speedometer on the dashboard of every car is an odometer, which records the distance traveled. If the initial reading is set to 0 at the beginning of a trip and the reading is 41 half hour later, what has been your average speed? So we are asked of, again, average speed. So the formula should be total distance divided by total time. So in this case, 40 kilometer is the distance, and then the time is 1/2 hour or 0.5 hour. So to compute, we have 80 kilometer per hour. So that is 40 divided by 0.5, that's 80 kilometer per hour. Would it be possible to attain 80 km per hour average speed and never go faster than 80 km per hour? So this one is, I have explained this one when I discussed average speed. So would it be possible to attain 80 km per hour average speed and never go faster than 80 km per hour? Is it possible? Now, if you start at 80 km per hour and maintains that velocity or speed, then it is possible. However, you cannot have an object that moves from a zero velocity to 80 km per hour in less than, let's say, a fraction of a second. So the speed is always from zero and then slowly increasing until it reaches 80 km per hour. So if you will get the average of, let us say, 0 km per hour plus 40 km per hour plus 80 km per hour, you would get an average speed of less than 80 km per hour. So in order for the average speed to be 80 km per hour and not less than 80 km per hour, the car or the object should go faster than 80 km per hour. So in this case, would it be possible? No, not if the trip starts from rest. So there are times in which the instantaneous speeds are less than 80 km per hour. So the driver must drive at speeds higher than 80 km per hour during one or more time intervals in order to average 80 km per hour. In practice, average speeds are usually much lower than the highest instantaneous speed. So if the highest instantaneous speed is 80, then the average speed is lower than 80. But since we want the average speed to be 80, so there will be moment that your instantaneous speed is greater or should be greater than 80. Okay, next. She moves at a constant speed in a constant direction. Rephrase the same sentence in fewer words. So, speed is constant, then direction is constant. So, since speed or magnitude only and direction refers to a vector quantity velocity, then we could say that she moves at a constant velocity. Since the magnitude and direction is constant, then we could say that she moves at a constant velocity. The speedometer of a car moving to the east reads 100 km per hour. The car passes another car that is moving to the west at 100 km per hour. Do both cars have the same speed? Do they have the same velocity? So which is which? Do they have the same speed or do they have the same velocity? Do they have the same speed? Yes, because their speed is 100 km per hour. So both of them have a speed of 100 km per hour. But do they have the same velocity? No, because one is moving to the east, the other one is moving west. So therefore, their velocities are opposite. So both have the same speed, but they have opposite velocities because they are moving in opposite directions. During a certain period of time, the speedometer of a car reads a constant 60 km per hour. Does this indicate a constant speed or a constant velocity? So the answer is constant speedometer reading indicates a constant speed but not constant velocity, because the car may be moving along a straight may not be moving along a straight line path, in which case it is accelerating. So it will not be at constant velocity if direction changes. And if it is not at constant velocity, then the object is accelerating. So that would be all for today.